As how are you doing now? Welcome back to this channel. Now in this lesson we want to unravel some question that has to do with nuclear physics pertaining to the half-life aspect. Okay, so we want to look at half-life, how to calculate half-life. We have actually dealt with the graphical method of solving half-life. So now we want to look at how we can calculate half-life. Okay, how we can get half-life using the calculation method. Okay, so now we have some question actually to unravel. And what does the question says? The first question says the half-life of carbon-14 is 5,730 years. Okay, how much is remaining from 100-gram sample of carbon-14 after 11,460 years? Okay, how much is remaining? So now, how do we unravel question of this nature? Now, solution to that. Now, they said the half-life of carbon-14 is 5,730 years. So let's write that down. So the half-life is 5,730 years. Okay, now the question is how much is remaining from 100 gram? So which means that the initial mass, okay, of the sample is 100 gram. So how much will remain from 100 gram sample of carbon-14 after 11,460 years? So now we can easily write this by saying the initial mass, which is 100 gram, okay, we reduce to have its initial value after this half-life, which is 5,730 years. So it's going to reduce to have its initial value, which is 50 gram. All right, so now after another 5,730 years, okay, so which means we're going to double this. So we have 11,460 years. So this will also be reduced to have its value. So we have 25 grams. Okay, so now what does that mean? We already know the concept, the meaning of half-life. So now they said the half-life of the sample is 5,730 years. So the initial mass was 100 gram. And the question is, how many of these 100 gram will remain after 11,460 years? So initial mass is 100 gram and has reduced to 50 after this year. So 50 we also reduce to 25 after we double this year. So after 11,460 years. So the correct answer to that glorious question is 25 gram. So which means that 25 gram will remain after 11,460 years. All right, so the answer to the question is 25 gram. All right, so quick one, we move to the next question. We have another question here. That will be the second question, using the calculation method to unravel concept that has to do with half-life. So the question says an element whose half-life whose half-life is 10 days. Okay, an element whose half-life is 10 days has a mass of 12 gram. Okay, it has a mass of 12 gram. Then we are asked to calculate the time during which 11.25 gram of the element would decay. Okay, we are asked to calculate here the time during which 11.25 gram of the sample would have decayed. So we want to look at the time the sample will have decayed. So now to solve that, write down the solution. Now the question says an element whose half-life is 10 days. So the half-life of that element is 10 days. So we write 10 days, and that is the half-life. All right, has a mass of 12 gram. So the initial mass of the element is 12 gram. So we are asked to calculate the time. Okay, time is what we're looking for here. We are asked to calculate the time during which 11.25 gram of the elements would have decayed. So now, how do we unravel that? Now, the initial mass of the sample is 12 gram. So we write 12 gram being the initial mass of the sample. So after 10 days, which is the half-life, the first half-life. So after 10 days, so this will reduce to half its initial value. So after 10 days, so we have 6 gram left. Okay, now we have to double these 10 days now. So 10 after 20 days now, this 6 gram will reduce to 6. So that is after 20 days. Okay, then after 30 days, we add 10 to this. So this 6 gram will reduce to its half, which is 3 gram. That is after 20 days. 10 plus 10, 20. So now, after 30 days, that is, we had 10, which is the half-life, to this. So after 30 days, 3 gram will reduce to have its initial value, which is 1.5 gram. All right. Then after 40 days, okay, we had 10 to this. We had the half-life, which is 10 to this. So 1.5 we also reduce to have, that is after 40 days. So we're gonna have 0.75 gram left. Okay, so now the question requires us to calculate the time during which 11.25 gram of the elements would have decayed. Okay, so 11.25 gram of the initial mass. Now, so after 40 days we have 0.75 remaining now, which means that 12 gram, which was the initial mass, when we take it away from 0.75 gram, okay, what we will have left is 11.25 gram. So which means that the mass that will remain is this, and that 12 has been decayed. Okay, so the question is calculate the time during which 11.25 gram. So 11.25 gram has gone out of 12 gram in 40 days. Okay, so this is what remain. All right, so now the correct answer to that question, that the time, okay, during which 11.25 gram has decayed is 40 days. Okay, I quickly revamped that. I quickly re-explained that. The question says an element whose half-life is 10 days has a mass of 12 grams. We have to calculate the time during which 11.25 gram of the element would have decayed. Okay, 11.25 gram of 12 would have decayed. So we wrote down the half-life, which is 10 days, the initial mass of the sample, which is 12 gram, and then also the time, which is unknown. We have to calculate the time in that regard. So now, what does that mean? So we write it down, the initial mass, which is 12 gram. Okay, after 10 days, it reduces to 6 gram. Okay, and 6 gram, after 20 days, it reduces to 6 gram. And then it reduces to 3 gram. And this 3 gram, after 30 days, we had in 10, 10, 10. After 30 days, this 3 gram reduced to half its initial value, which is 1.5 gram. Then we had 10 to 30. So after 40 days, 1.5 gram reduces to 0.75 gram. Okay, so now, which means the mass remaining is 0.75 gram, and that 11.25 gram has decayed. Okay, so 11.25 gram has decayed in 40 days. Okay, so that is the glorious answer to that question. All right, so now we got another question here to unravel. This is another question. Let's quickly look at it. And what does it say? The question says, and I read. Now the question says, the half-life of a radioactive element is 24 hours. Okay, the half-life of a radioactive element is 24 hours. So we are asked to calculate the fraction of the original element. Okay, calculate the fraction of the original element that would have disintegrated. Okay, that would have disintegrated in 96 hours. We should calculate the fraction of the original element that would have been disintegrated in 96 hours. Now we solve sequentially. The half-life has been given to be 24 hours. All right, so we are asked to calculate the fraction that would have calculated the fraction of the original element that would have disintegrated in 96 hours. Now let's say the original sample is 1. That is the initial quantity of the sample. Okay, so now after 24 hours, now this 1 would have decreased to half its initial value, which is 1/2. Okay, that is after 24 hours. Now after another 24 hours, so 24 plus 24, that's 48. So which means after 48 hours, so this would have also reduced to its half, which is 1/4. That is 1/2 multiplied by 1/2, you get 1/4. That is after 48 hours. Now we had 24 again. We had 24 to 48. All right, we are not doubling this 48, please, but we just had 24 to hit. So when we had 24 to 48, what do we have? So 24, 48, that is 2, that's 6, that is 72 hours. So which means after 72 hours, after 72 hours. So this would have also reduced to its half, which is 1/8. Okay, so we had another 24 to this. So when you had 24 to 72, so that will be 96. So after 96 hours, then the mass that would remain is 1/16. Okay, so now the question says we should calculate the fraction of the original element that would have disintegrated in 96 hours. Okay, so the mass remaining is 1/6. Okay, mass remaining is 1/16, rather, not 1/6. Okay, mass remaining is 1/16. Then the mass that would have disintegrated, mass that has disintegrated after 96 hours, therefore is 1 minus 1/16, okay, which is equal to 15/16. So which means that 15/16 has disintegrated from the initial mass. Okay, 1/6 is the remaining mass from this initial mass 1. This remain, but the mass that has disintegrated after 96 hours is 15/16. All right, so that is the answer to that question. Now also there is this question which is also essential for us to know as well. And what does the question says? The question says the half-life of a radioactive element, okay, is 3 days. The half-life of a radioactive element is 3 days. Now if a sample contains initially S gram, okay, if a sample contains initially S gram, okay, of the element, after 12 days, all right, so it will contain what? Let's get the question right. It said the half-life of a radioactive element is 3 days. If a sample contain initially S gram of the element, okay, if a sample initially contain S gram of the element after 12 days, okay, sorry, if a sample contain initially S gram of the element, comma, after 12 days it will contain what? Okay, what will it contain after 12 days? So how do we unravel question of this nature? So solution to that. So the half-life has been given to be equal to 3 days. Is that clear? Now, so if a sample contain initially, so the initial mass of the sample has been given to be S gram of the element. So then the question now is, after 12 days it will contain what? So after 12 days, what are we going to have? So the initial mass is S gram. Okay, so now S gram after 3 days, which is the half-life, it reduces to have its initial value, which is x over 2. That is after the first half-life. Then after 6 days, so we had 3 to this initial 3. So after 6 days, so this we also reduce to half, which is x over 4 gram. Okay, so now after 9 days, this will also be reduced to half. We have x over 8 gram left. And then after 12 days, what do we have? So after 12 days, you had 3. We added 3 to 3, we got 6. We added 3 to 6, we got 9. We added 3 to 9, we got 12, because the half-life is 3 days. So after 12 days, what we have left is x over 16 gram. So now, the answer to that question is x over 16 gram will remain after 12.